we're asked to find the equation for a line that passes through the points 0, 6, and 3, 0. So let's start by writing down the standard form of the equation for a line, which is y equals mx plus b. Okay, if you remember previously, we did this problem where we had, the line was graphed for us, right? And we saw that the y-intercept was at 0, 6. So this is the y-intercept right here. So b will be equal to 6. But let's assume that we didn't notice that, and then we're going to progress forward with a more analytical method, and this method might be one that you choose to use. So let's try it out and see how it works. So the first thing we'll do with this analytical method is we'll find the slope. To find the slope, we put the points one on top of the other, and it doesn't matter which one you put, and you just subtract one from the other. So let's put 3, 0, divided, minus, not divided, minus 0, 6. So we have 3 minus 0 is 3. 0 minus 6 is negative 6. So this is your change in x, and this is your change in y, right? And so the slope is equal to delta y over delta x, and it's equal to negative 6 over 3. And this is equal to negative 2. Notice I didn't use the words rise over run, because in this case, actually, we remember from previously, the graph looks something like this. So there's actually a fall, right? A drop and then a run, right? So we just annotate, the change in y by delta y. And it could be a drop, it could be a rise, but we just annotate it by delta y, right? And so we see that this is equal to negative 2. Now we could have, inadvertently not chosen the x value with the greatest amount. Like, you want to pick the point that has the greatest x value and then put that one on top, right? And then this is the run and this is the quote rise, but really this is a drop, right? Because it drops by an amount of negative 6. It goes down, and then this goes over 3, right? So, but what if we put them in a different order, right? What if we do 0, 6 minus 3, 0? This is the beauty of this technique. You can't go wrong. 0 minus 3 is minus 3. 6 minus 0 is 6. So this is your delta x. This is your delta y. So then m is equal to delta y over delta x, which is equal to, the delta y is 6. The delta x is negative 3. So we have 6 over negative 3. Well, that's still equal to negative 2, isn't it? The difference is with this method, now there is a subtle difference, but you just got the right answer, right? And that's what really counts, right? This is you'll get the right answer no matter what. It's almost foolproof, right? So the difference is for this one, you basically were going backwards the other way. You went from here to here, and then you rose up by 6. So you went backwards by negative 3, and then up by positive 6, right? But the slope, the slope is the same. The ratio of the two is always equal to the same thing because it's the same line. So this method is a good bookkeeping technique that should not fail you, should not ever fail you. It won't fail you if you're careful. It's usually just careless errors that get you, but this is a really clean way of avoiding careless errors. So, okay, so the next thing we do, now that we have the slope, we say y is equal to mx plus b, right? And so we know what m is, right? We know that m is equal to negative 2, so let's put that in there, right? Now that we've solved for that. So now all we need is b, and we've solved for the equation of the line. So let's plug in one of these points, but then we could pick either one of them. So let's pick this one, 3, 0. But let x equal 3 and y equal 0, right? And this is just akin to making sure that this thing goes through the point 3, 0. Right? This is the same thing as saying this, right? So y is equal to 0. X is equal to 3, so negative 2 times 3 plus b. So we have 0 equal to negative 6 plus b. Add 6 on both sides, plus 6. And so b is equal, you see this cancels, and we see that b is equal to 6. Therefore, y is equal to negative 2x plus 6, as expected, because we did this problem previously with the graphical method. Right? Okay, so it's very little room for error with this technique. I encourage you to use it. It will serve you well. I'm going to step out to the side and give you a clear screenshot. Try it out.